Hello everyone, welcome back to another episode of the technology series and also another episode of the design pattern. So till now we have learned few parts of WordPress, few parts of design patterns, in design pattern we have learned about the repository pattern. While learning about the design pattern there were many concepts that we went through which I wasn't able to fulfill all the concepts in one episode, and that is why I'm coming up with one more episode, and this episode is the IOC, that is inversion of control. So inversion of control is one of the most important concepts that every programmer should learn in their early days of programming. We usually tend to skip it because our days are so busy and we mostly focus on delivering the work that we have, the program that we got to write. But we usually forget to learn about how efficiently we can write the program, so that if you are an entrepreneur, if you are working in any organization, or you are a freelancer, if you want to scale up your application, if you want to give more suggestions to your customers, more efficient code to your customer, so that you can confidently say that tomorrow, sir, tomorrow if you want to scale your application, I will be doing it for you without changing the existing code. I know that not everyone thinks about it, but this is one of the most important parts of programming that you should know. And we are heading towards it. This is the second episode. We'll be doing more episodes on efficiency, on optimizations of the code. But let's start learning about inversion of control today.
In my previous video, I spoke about dependency inversion principle, inversion of control, and dependency injection. There is a lot that we can do in inversion of control, hence I wasn't able to cover that in my previous video. But this time, in this video, we are going to talk a lot more about inversion of control, what are the types of inversion of control, how it can be implemented, and why we should adapt inversion of control concept in our programming. So further in this video, we are going to discuss callbacks, schedulers, event loops, dependency injection, and template method. I'm not going to talk much about template method here because that's not related to coding, like the application programming. So I'll keep it limited to the four. But before that, I would like to jump into an example of how you can control using Node.js. So let's get right to it. So I've created a very simple Node.js app, created app.js, created few other JavaScript files where there are classes. Now let's go line by line in app.js and check what we are doing here. In the first line, we are importing the router, that's fine. Express, that's fine. From line number 4, I'll start explaining what's happening here. I am importing the regular.js file. The regular.js file have the procedural method of programming. The line number 5, it has the dependency injection class, that is the di-class.js file. Okay, we are writing a class over there, and I'll show you what we are doing there. On line number 6, we are importing a user repository class. So what are repositories? I'll paste a link. It's repositories are explained in my previous video. I'll paste the link. You can go and check it out. On line number 7, we are instantiating the user repository class. Okay, I'll explain why are we instantiating it in this file. On line number 8, the di class, we are again creating an object of the class of the dependency injection class. Okay, now what are we doing exactly here on line number 8? We are injecting the user repository object. That means instead of calling or instantiating the repository inside the dependency injection class, that is a di-class.js file, we are passing it as a dependency injection object. Okay, so that's where our entire concept of inversion of control kicks in. and why it is important. I have explained it in my previous video and in the past few minutes. Alright, let's go down, skip few lines, let's go on line number 15. Now on line number 15, we are executing the regular script, that is a procedural method, and on line number 16, we are executing the DI class object. Okay, and this is the method where the inversion of control concept kicks in, is implemented. Okay, now let's go ahead and open the regular.js file. Okay, so in regular.js file, we see that on line number 1, we are importing the user.js file. On line number 2, which is important, we are importing the user repository file. On line number 4, we are instantiating the user repository class in this file. Okay, so the difference between dependency injection and procedural method is that all the all the process of instantiating a class, calling its functions and objects is done in the regular.js file, and this is the normal way, the procedural way of programming. The next line, on line number 6, then we are calling an async function. We are using the object of user repository and then calling the get all users function. Similarly, on line number 13, we are doing the same thing, using the object user repository and calling the add user function. From line number 16, we are exporting these two functions, that is on line number 6 and line number 10. We are exporting it so that we can use it in app.js. Now, if you all have understood the regular procedural way of coding here, let's move on to di-class.js file. Alright, so here we are creating a class, and inside a class we have created a constructor, and then we are creating functions. So now the difference here is IOC, inversion of control, is implemented in this class. So in the constructor, we are using the user repository the user repository class that was injected into user service from app.js. Okay, let's relate. Let's go back to app.js file. On line number 8, we are instantiating the object of di class script, and we are passing the user repository object to its constructor. Okay, and that is how we are using this as a dependency injection over in the user service class and in the constructor. Now we are going to run this script in the terminal of Visual Studio. Now we are going to run this script in the terminal. Let's start a new terminal and let's type node app.js. So you see that we got, you are viewing procedural method, you are viewing dependency injection. Both the ways, procedural way and the dependency injection way, or I would say the class way, are both calling the same repository but in two different ways. So here we are getting a better clarity on how inversion of control works, what kind of a design pattern it is. And again, as my previous video, I've used dependency injection to implement inversion of control design pattern. Coming back to what all is involved in inversion of control. The first is callbacks. Let's talk and take a look at callbacks with an example. So there are two parts in which we can check how callbacks work. there is a synchronous callback and there is an asynchronous callback. Let me go ahead and show you an example of both. So you see the line number 2. I have written a function, that is my function, passing some attributes to it, that is a, b and callback. So callback, the third parameter, is a function. Okay, that's a callback. So on line number 7, you see the display sum. There is some kind of manipulation happening, and then we are inserting the sum into the total value element in the DOM. Now on line number 11, I'm calling the my function, that is from line number 2, passing the value 5, 4, and the third parameter is the display sum function. Okay, so eventually what it is doing, it is calling the my function, passing the values, the first parameter, the second parameter, and the third is the callback function. So eventually what is going to happen, that every step is happening one after another. It's not waiting for or not running anything in the background. Okay, so that's how a synchronous function and a callback function works in a synchronous way. This is an example of an asynchronous function. So we are using a set timeout function that will execute after 3 seconds, and we are passing a function called my function as an argument. So similar, what is going to happen here, the function is going to be called as soon as the set timeout function triggers, but my function is going to trigger only after 3 seconds. Okay, so that is the difference between the first example I gave for the synchronous function, which runs one after another, and this asynchronous function has a waiting time. So it runs in the background, and then as soon as the 3 seconds are over, it triggers. The second part of inversion of control is schedulers. So in computing, scheduling is the action of assigning resources to perform tasks. Now, what does that mean? There are different type of tasks. It may be threads, processes, or data flows. So I'll be discussing more about threads and processes because data flows is a part of networking, so I'll just skip that. So let's talk more about what are processes and how it is handled by a scheduler. Again, in computing, a process is a bunch of computer programs executed by one or many threads. I'll give you an example. Now, a program can be, for example, an audio recorder. So an audio recorder, when you start an audio recorder in your operating system, there is a process running in the background, and then with the process there are threads within that process. So this is just audio recorder is just one example of a process. One more process can be your video player, it can be your music player, it can be a browser. So these are all the processes that is handled by the scheduler in any operating system. In an operating system, the process is made up of multiple threads, and that executes maybe it depends on your operating system whether it can have concurrent operations or it cannot have concurrent operations. So now these days, I mean not even these days, from the past decade or so, mostly all the operating systems are can handle concurrent processes. So on the right hand side of the screen, if you see, there is a vertical section which has process number 1, process number 2, and process number M. So so this is an example of an operating system running multiple processes together, but a scheduler is responsible to execute the process on basis of the priority of the process. Coming to threads now, threads are a part of the process. So as I said, a process can have multiple threads going on. So a thread is the smallest part of the programmed instruction that can be managed independently by a scheduler. So in this diagram that you see, the scheduler is pointing to multiple threads. Okay, thread number 1, which is on the highest priority, thread number 2, 3, 4, and likewise thread number k, that is on high priority. So what happens is that whenever a program is running and it's already like a stack of threads with the scheduler, so the scheduler knows its priority. Now, what does preemption mean? You see the arrow, the curved arrow, which is showing the preemption text. Sometimes a new thread starts and the scheduler understands that the priority of the last thread in the stack is high. So it deviates from the sequence, executes the thread which is on high priority, and then goes back to the normal execution of the thread. So scheduler plays a very important part in any operating system or in any program. As we know that a process has multiple threads, so multiple threads can be executed concurrently. That means all the threads of a given process, okay, one process, multiple threads, all the threads of a given process shares memory, pieces of the executable code, and the dynamically allocated variables. So, let me explain it further. A program, for example, a program written in Node.js, right? It is a single thread scripting language. But what happens is that multiple threads can be created and it executes in the call stack simultaneously. Depends on the priority and depends on where it is in the stack. So this is more about schedulers or schedulers in an operating system. Now let's move forward to event loops and understand how event loop works. This diagram is a very basic understanding or layout of how an event loop works in JavaScript. So y'all must have heard about the V3 engine of Chrome, right? So JavaScript uses, or in fact Node uses the V3 engine of Chrome and runs Node.js. So let me explain a bit more about this diagram that we have created. Okay, so JavaScript is an interpreted programming language. On the right hand side, you will see the web API. Now, what is a web API? Web API has a lot of functions that can be used in the browser. So set timeout, Ajax is one, are few of the functions that can be executed on the browser. All right. Why it cannot be integrated in a Node.js code is because Node.js has a different way of working which is in the background. That is why it is a backend programming language. The concept of event loop is very beautiful, and that's what makes Node.js such a powerful interpreted programming language which executes your code and handles your code so well that many applications these days, high scalable applications, complex applications are built on Node.js. Especially APIs, microservices, and everything are built on Node.js because of its efficiency and the way of handling programs. It's a single thread programming language, but it still can handle a lot of asynchronous functions together. So as we know that inversion of control is a design pattern, right? There are multiple ways to implement this inversion of control, the design pattern. So event loop is also a design pattern that waits for and dispatches events or messages in a program. What does that mean? If you see the diagram carefully, you will see the event loop on the lower end of the diagram, where there is an event loop and there is a polling inside a circle, right? So this event loop polls the callback queue, pulls what is available in the stack, and then sends it to call stack. That's how the call stack gets filled with what all program or threads needs to be executed one after another. Talking a bit more about how event loop communicates with the call stack and the callback queue. So event loop communicates with the call stack and callback queue. It checks if the call stack is free. Okay, free means whether it has available space or available memory to pick up some programs which are there or some functions which are available in the callback queue and put it in call stack. So we are done with the event loops here. It's a beautiful concept. Go ahead and research more about event loop, how it works. You will become more efficient in programming. The last section of this video is talking more about dependency injection, which I've already done before in my previous video. Check out the link on top right corner of the screen and learn. It's a must for every programmer. As I said at the beginning of the video, template method is one more design pattern, but it will be an over absorption of information if I explain this design pattern. Let me know if you want me to create a detailed video on this with some easy to learn examples.
Whoa, that was exciting, right? So after doing so much of mehnat behind learning what is inversion of control and how to implement inversion of control, different ways of implementing inversion control. So there is a lot of fundamentals behind it which you need to learn first, understand in order to understand what to write and why are you writing it. So, me or someone else or some textbook or some online courses, when they show you that this is how the program is written, a lot of people, tend to not tell you why the program is written in that way. The concepts are already there, but you need to know the core of the concept. Why is the concept introduced in programming so that, you can write efficient programs. But this is an FYI for everyone that whenever you're writing a program or whenever you're looking at a program online, try to understand why it's written in that way. If you do not understand any part of the program, just go online research. Just go online research for the keywords and try to understand the concept of that keyword. Why is that written in that way? All right. So here we are at the end of the episode, and we'll be coming up with one more episode soon. But till then, if you like the video, if you like the concept of inversion of control, why is it used, how it is used, go ahead and implement, man. Go ahead and implement it in your programming language, whichever programming language, right? It's just it's a fundamental thing which you need to learn and implement, whether it is Node.js, whether it is PHP or C#, any programming language. Just go ahead and try it, and if you are able to successfully build it, share this knowledge with everyone. I'm telling you guys, share this knowledge with everyone. Your juniors, your seniors, whoever is not following, whom you know that they program but they do not follow this, push them towards the progressive life in in their career, because if they progress, people who they know will progress, right? Why to keep the progress with ourselves? Why to keep the knowledge with ourselves and leave the world behind? Let's take the world with us and go ahead. All right. So all the best, everyone. I'll see you in the next video. If you like the video, give it a thumbs up, share it with everyone, and subscribe to my channel if you want to see more videos. All right. Thank you, guys. See you soon.